Hello and welcome to another one of D's ADD videos. Today we're going to look at an application of the squeeze theorem by looking at this example here. The way this problem sits, plugging into the x cubed is fine. That will give you a 0, but because of this x in the denominator, the limit of this one doesn't exist. So you can't do the individual limits like you would normally do if you were looking at a product, limit of products. You would change it into the product of their limits. But because this second limit does not exist, it's supposed to be x. Let's just erase that. Try that again. An x. And this one does not exist. We can't do that, so we have to approach it in a different way. So we recall that sine is a function that oscillates between two values. We know that the sine of whatever, in this case 1 over x, is going to be always greater than the negative 1, its minimal value, and smaller than its maximal value of 1. Well, what we're doing here is we're going to try to set up this equation that I have up here. Well, we're just one step away from that very thing. We just need x cubed. So let's multiply x cubes everywhere. And when you distribute that x cubed through, you're going to get a negative x cubed, the function we want. And then a positive x cubed. So what we've now established is the fact that the function we are looking at is always smaller than these two peripheral functions on the top, on the bottom, and on the top up here. So if we can find the individual limits of x approaching 0 for negative x cubed, which in this case would be 0, and the same thing would be true for positive x cubed, and it should be right the way we designed it. So because your f of x in this case is x cubed, and your g of x is your negative x cubed, and your h of x, your central term, is your x cubed sine over x cubed, not subscript. And what we have just now established is that we know now that g of x is smaller than h of x, which is smaller than f of x. Okay, that's what we proved right there. So then we, after that, found the two limits of the peripheral functions, this one being your g of x here, this one being your f of x there. So now what we're able to do is we're able to apply the squeeze theorem, saying that because these two top and bottom functions have a limit of 0, this middle function, therefore, the limit as x approaches of 0 of that middle function gets squeezed in between those other two functions to give you 0 as well. Alright? I hope this has clarified how to use the squeeze theorem. There are other applications, but this is the one we're doing now. Make sure you practice, 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 and check out the other example videos. Thank you and have a nice day.